Um, so I'd like to introduce myself. Hello, everyone, and welcome. My name is Eric Glenn, and I am the Program Manager for Safety. We appreciate you joining the webinar on data mining Twitter to improve automated vehicle safety. You all have come into the meeting muted, and we would appreciate if you stayed muted until the Q&A session. If you have any questions during the webinar, please type them in the chat box, and they will be addressed at the end. At this time, I'd like to introduce our two presenters. The first will be Dr. Tony McDonald. He's an assistant professor and the Corey and Jim Ferber 64 faculty fellow in the W.M. Michael Barnes Department of Industrial and Systems Engineering at Texas A&M University, and the director of the Human Factors and Machine Learning Lab. His research focuses on integrated human factors methods and models with the machine learning algorithms to develop technology that improves transportation safety and health outcomes. Dr. McDonald was a recipient of the 2019 Human Factor Award for Excellence in Human Factors Research and the 2020 Stephanie Binder Young Professional Award from the Human Factors and Ergonomics Society. He has received his master's and PhD in industrial engineering from the University of Wisconsin-Madison in 2012 and 2014, respectively, and his bachelor's of science in mechanical engineering from MIT in 2010. His second presenter, Dr. Bert Hong. Dr. Hong is an assistant professor in the Department of Computer Science and the Data Intensive Studies Center at Tufts University. He earned his PhD from Columbia University in 2011, was a postdoc at the University of Maryland, and previously was an assistant professor at Virginia Tech. His research addresses topics surrounding machine learning. He focuses on modeling complex phenomenon, learning in settings with low quality data, and making algorithms more fair. His papers appear at conferences including NURI IPS, ICML, UAI, and AI Stats. He is also an action editor for the Journal of Machine Learning Research. So, without further ado, I'll pass it on to Dr. McDonald.
Thank you, Eric, and thank you everyone for joining today on your lunch hour or post lunch hour for those on the East Coast, and I guess pre-lunch hour for those further west of the Midwest. So as Eric mentioned, Bert and I are going to be talking about data mining Twitter to improve automated vehicle safety. But I wanted to start with talking about where we're at right now with AVs and in general automated vehicle technology. So we have had some big wins recently in terms of advanced safety systems like automated emergency braking and forward collision warning, which have been shown to decrease certain types of crashes by as many as 50%. There's also a lot of information about the promise that vehicle automation will bring, such as reducing transportation costs between $2,000 and $4,500 per AV, and then also substantially improving safety. However, more than 50% of drivers still have significant concerns about AVs, and safety is one of the most commonly cited concerns. And we also have been seeing some incidents that are a little bit concerning in the other direction, which is where we have documented incidents of users over-relying on automated technology. So technology that's designed to have someone in the driver's seat monitoring it. We see videos of people who are sleeping while that vehicle's in that automated mode and obviously not monitoring the technology. And these are starting to accumulate as this technology gets more and more time on the roadway. Now, what we have seen, though, is that we can influence this type of perception. There's been a couple studies that have looked at providing drivers with narratives that clarify safety issues, and these things can increase adoption intent. But then in the other direction, we've seen that when widely reported AV crashes happen, they actually negatively bias AV acceptance, as shown in responses to surveys. And what we're really after here is what's called trust calibration. And so typically we talk about trust calibration with this type of diagram here, where we have trust in the automated vehicle on the y-axis, and then the trustworthiness of that automated vehicle on the x-axis. And perfect trust calibration would follow this line here. So for every incremental increase in AV trustworthiness, we have a corresponding increase in trust in the automated vehicle, and then same thing with decrease going the other direction. And what the literature suggests is that when we have things like new technology come out, big announcements, positive media attention, that pushes this trust above the calibration line. And what happens there is we have these over trust situations like I talked about with sleeping in the back seat of a car that's in operation. And then when we have things like high profile crashes or critical media reports, those push below the line, which is where people don't use or don't trust AV technology, even though it may help them drive safer. So we don't get the promise of the benefits in that case. And we feel that, or at least our hypothesis in starting this project, was that social media is really key to understanding those arrows that push things up and down. And why are we looking at social media, and specifically, why are we looking at Twitter? First off, the Twitter demographics overlap considerably with the AV user or intended user demographics. Second, Twitter is a news source for nearly 75% of its users. So I mentioned media has a big role in pushing things up or down on that trust calibration line. And when many people are getting their news from Twitter and reacting to that news on Twitter, we should be able to capture those changes. And then finally, crashes and AV safety are frequent topics of conversation on Twitter. We found this in kind of a pilot analysis, just generally searching terms, crashes, and events on Twitter. Now, Twitter is not without its challenges. So the first and probably biggest one is identifying relevant tweets related to events. So we know an event can happen and we might be able to search for keywords, but if you've ever had a conversation with someone, or if you're an active Twitter user, what you can see is that the conversation often quickly drifts away from these terms, these keywords, even though it's still related. The second challenge is that once we are able to gather the relevant tweets, it's very hard to convert those into user perceptions of AVs. We could read thousands and thousands of tweets and try to develop a consensus, but that's really an intractable problem in this case. So we need something more automated. And then the last challenge is to translate those user perceptions into actionable change, right? So the second step here will help us understand what's pushing the arrow up and down, but it won't help us kind of calibrate to keep that arrow or keep things aligned in that trust calibration line. So we addressed the first issue with developing a novel search algorithm for AV event-related tweets and broadly event-related tweets. And then Bert will discuss that next. And then the second thing, to address the second problem, we use probabilistic topic modeling and sentiment analysis to understand user perceptions of AVs from the tweets that we found. And then we address the final step here by combining the knowledge from that analysis with a user-centered design process, or at least user-centered design principles, to develop guidelines for social media reporting on AVs. So with that, I'll pass things over to Bert, who, as I mentioned, will talk us through our Twitter search methods.
All right. So this is an overview of the search strategy. At a very high level, we're going to try to use machine learning to filter a large collection of tweets down to the relevant ones. And we collect the large, so the first two stages of this flow chart try to gather a sort of an overzealous collection of tweets, so tweets that are relevant, but also tweets that might be relevant, but where most of them actually probably are not relevant. And then the last phase, we use machine learning to filter that down. And we're going to use a specific form of machine learning called weakly supervised machine learning, which I'll talk about. But let me go over the details for the first few phases first. So first, we do what probably would be the first thing you would try anyway, if you weren't going to use something more advanced. The first thing you would try is do some kind of keyword search filtered by date, right? That's a pretty natural thing to do. If you're looking for tweets relevant to a particular event, you will look for keywords related to, the topic that we care about, which is automated vehicles. And you would filter it by being in a date range where it makes sense that people would be talking about this event. And we limited the search to 2 days before and after the news release. Part of having it before was just to cover the fact that the news release might not be the first time that Twitter users knew about the event. And also it's useful to have before and after for analysis. And then the keywords we chose, we just manually came up with a list of keywords that we thought would be capture a lot of the relevant tweets. But they all, even if you look at the keywords, some of them would be more precise than others. Like for example, hit and kill. Those are words that you would use for sure in a discussion of a car crash, but they would also be used in other contexts. And same with Google, and there's a bunch of words that might not be relevant or have different levels of relevance returned. So already there's room for cleanup here. So after we do this date limited search, we do an expansion. So we want to, again, like as Tony said, we want to collect sort of the ongoing conversation. After someone used this keyword, there might be other conversations sort of back and forth with other users that doesn't use the keywords anymore. So what we look for is any tweet that is in that date range that was tweeted by the users who posted the original tweets that came up in our search. So if someone posted this tweet, did you see the news about the new driverless taxi? And we have the keyword driverless. We would then collect all the other tweets that they posted during that time period. And of these tweets, there might be ones where they mention other users, or within these tweets, there might be ones where they mention other users. So for example, they might have mentioned this user car parts too, asking if they're going to carry parts for these new cars. And then our search algorithm then collects the tweets generated by that other user as well. So the hope here is that we capture any sort of back and forth conversations that might happen about the original tweet. And you can imagine this procedure gets us a lot of stuff that's not relevant, but the hope is that it has a good recall, right? So it captures a lot of the stuff that actually is relevant. Ideally, we have a good proportion of that at the cost of having to also capture a lot of junk. So we want to now filter the junk. So to do that, we do machine learning. And one way we could have done this, had we wanted to spend the time, is to do sort of traditional machine learning, what's called fully supervised machine learning. And you've seen things like this all the time, like the reCAPTCHA system, where it asks you to like mark the bridges or the crosswalks. Those are systems where they're asking people to go in and label individual examples. And it's a very painstaking, long process to get enough labels that you can train a complex model or a model for a complex concept. And what we've leaned on instead is something called weakly supervised learning, where instead of, this is a diagram of what fully supervised learning looks like. You have a set of unlabeled data, and then for every single example in that data, you have a label. And you can pretty much assume that each of the labels is 100% correct. And you feed that into the learning algorithm, and that's fully supervised learning. And that's expensive because getting all these labels is just costly. It takes a lot of time. It takes a lot of human effort. So we wanted to do something called weakly supervised learning instead, which is cheaper in many contexts. And the idea there is you still have this huge amount of unlabeled data, but rather than labeling each example in that data set, you come up with rules that approximately label the data. So you might have one rule that is like 62% accurate, right? So it's going to be wrong quite often, but it's better than random. It's better than random labeling. And you might have another rule that's 78% accurate that captures a different idea. And in I'll go over the specific rules we use, but the challenge for the machine learning algorithm here is that we have to handle the fact that these rules are not completely independent of each other, right? If they were completely independent of each other, you can just sort of take the average rule and you get a pretty good estimate of the labels. But there's sort of a lot of machine learning research going on how to handle the fact that some of these rules might be redundant. They might use the same information. They might be biased, right? They might be biased in the same way, and so that can be something that needs to be handled. So the rules we specifically used for this project were, we looked for, if one of the original keywords was present, we assumed that it is more likely to be relevant than if there was no keyword present. We figured if there's a URL in the tweet, it's likely to be relevant, or at least discussing a news article. So we thought it would increase the likelihood that it's relevant. We checked whether the tweet is detected to be relevant by an unsupervised topic model. This is where we trained a topic model kind of similar to the ones that we will talk about in the next segment of the talk. And we manually labeled the topics as whether it seemed relevant or not. And so by labeling just a small set of topics, we can quickly label the whole data set in a noisy way. And then lastly, we clustered the data set and then manually looked at each cluster and decided whether those clusters looked relevant or not. And we clustered those using semantic vector representations of text. So these are tools that have been coming out, I guess, in the past few years now, but they keep getting better and better each year. We used kind of an older method called the glove method, but it's the idea there is that there's numerical representations of text that try to preserve semantic meaning. And so we use that for the clustering. So I don't have to go into details about this, but we used a specific new algorithm for weekly supervised learning that we've been developing. This has been published, or it will appear at UAI in a week or two, I think 2 weeks from now. And the principle here is that we define a space of possible true labels of whether it's relevant or not. And that space is defined by the weak signals, by the weak supervision. And we just try to find a set of labels that are consistent with the weak supervision. And then we train a machine learning algorithm to match that set of labeling. And then that final algorithm in the end lets us, gives us a function that we can just sort of ask it, is this tweet relevant? If we get a new tweet that we haven't seen before, we can then ask that function whether it thinks it's relevant. And this is the evaluation we ran for some offline tests to verify that the method works. And the takeaway is that, what we're plotting here is the precision. There's the precision, the recall, and the F-score. If you look at the F-score, that's the summary statistic that combines precision and recall. We are consistently do better than just taking the average. So MV is majority vote, meaning we're essentially looking at all the weak signals and taking treating each of them as a vote and taking the majority of whether some will vote that the tweet is relevant, some will vote that it's not relevant, and whichever one is more common wins in majority vote. And so we get higher precision and recall in general on all of our different events that we compared.
Okay, so once we validated the search method, then we had a more targeted search over a broader set of AV events. And what we tried to do with these events, and we sampled 12 of them, is that we wanted to get some positive events, things that may move things up on that trust calibration line. So these are mainly centered on kind of major tech announcements, kind of the first announcement announcing Tesla Autopilot, also some big advancements in the M-City environment, and then an announcement from Audi as well. And then we looked at two types of crashes, one more negative, which would be highly publicized fatal crashes, and then also some kind of more minor crashes that had some unique features, like the Las Vegas automated shuttle that had a crash on its first day in operation, a Tesla crash that happened in 2019 in New Jersey, where the driver indicated that the vehicle was confused, and then also an example from the California's DMV's autonomous vehicle testing crash database. So our idea here was to sample both good and bad and neutral events, and then also try to pull from things from different stakeholders. So things that involve government, things that involved companies, and also things that involve universities as well. Kind of all the sort of major stakeholders involved in autonomous vehicles. And then once we gathered those tweets with our weekly supervised learning search, we did some pre-processing for them. So we removed things like hyperlink information, so like HTML codes and things like that, tags and hashtags, and then pictures and emojis. So the probabilistic topic modeling approach primarily or consistently operates just on words. So we had to remove kind of the extra content. And then we extracted word tokens, and we retained the nouns, the verbs, and the adjectives. And then we did a process called stemming. So stemming breaks words down into their morphological roots. So this helps, again, with the consistency. So the words break, breaking, and braked. In typical topic modeling, without this step, they would just be considered as 3 separate words. But by stemming them into BRAK, then they all are considered kind of the same word. So we can see that consistency there. Then we removed stop words and removed words that were less than 3 letters and tweets that contain less than 3 words. And then finally identified and removed the duplicate tweets. So after we did that step, this is our final data set. And as Bert mentioned, we had tweets both before the event and after the event. And then we collected data, as I mentioned, from the 12 different events. And you can see this ranged in size from somewhere down to like 3,000 relevant tweets all the way up to over 15,000. And then once we had that data set, as I mentioned, we applied probabilistic topic modeling. So if you're not familiar with the PTM technique, essentially the goal is to find themes or topics in a set of documents. And so the documents in this case were our tweets, and then the topics were sort of themes that we observed among those. And then the topics themselves also have words associated with them as well. And these words help us interpret kind of what's being discussed in that topic. And all of this is probabilistic. So a given tweet could mention multiple topics, and a given term or word could also be present in multiple topics as well. And then for fitting the probabilistic topic model, we optimized 3 different hyperparameters: the topic sampling rate, or alpha, the word sampling rate, or beta, and then the number of topics. And we optimize this by using 2 quantities, the topic coherence and topic diversity. So topic coherence is the kind of inter or within topic consistency, and then topic diversity is sort of separating out the different topics from one another. And then after we gathered our topic model, or we developed our topic model, we performed a sentiment analysis, which is to understand the kind of emotional valence associated with the individual tweets. And you calculated sentiment by using the sentiment R library in R, and that is essentially done by looking up words in a sentiment dictionary. So positive emotional words like good and safe, those have positive sentiment values. And then negative words like bad, dangerous have negative sentiment values. And then one of the unique things about sentiment R is that it also includes kind of both the counts and then what are called valence shifters. So these are things where if we say not or very or barely, it kind of calibrates the sentiment to that. So an example here, if we said safe, we might give that a sentiment score of 1. But then if we said not safe, so the not being the valence shifter there, that would bump the sentiment score down to -1. So here are the results of the probabilistic topic model. And what we're showing here is the terms or words associated with a topic. And then each topic is shown in an individual figure. And then the bars here represent kind of the strength of the word association with that topic. And what we derived from this is 6 different topics. And the 6 topics we identified as crashes, fault and safety, market and sales, tech companies, electric vehicles, and public transit. So these were kind of the main topics that were discussed among the tweets that we found and across all the events. And then what this figure here is showing is by the events categorized by whether they're a fatal crash, a minor crash, or a technology advancement or announcement, and then the distribution of topics across those tweets. So as you can see here in the fatal crashes, crashes and fault and safety themes were the most prevalent and the most common. And then in the minor crashes, things were a little bit more distributed across those topics, as well as the marketing and sales and tech companies. And then for the announcements, primarily the focus here was on tech companies, which isn't quite surprising given that many of these examples are coming from tech companies making big announcements. Now, one thing that you'll note from this figure, if you look at it closely, is that there does seem to be a little bit of inconsistency here. So it's probably surprising to see that fault and safety is a big discussion in the announcement from M-City. And so part of this is due to just general discussions about how this could be used to improve safety. But also there was a report that came out about a fatal crash right around the time that this event came up. So there's some noise in the topics. And that's something that we wanted to see here. We wanted to sort of get an overall sampling with these big events and kind of what is the conversation going on around AVs. And then what this is showing now is when we expand out to look at 10 days after the event, the trends in the topics over time. And one thing we can see here with a lot of these examples, and so you'll see the crashes topic here is in orange, and then the fault and safety topic is in gold here, is that you'll see this trend where there's a lot of discussion kind of shortly after the crash happening, and then that will sort of peter out over time and some kind of stabilize and go back down. And you can see kind of spikes in all of these events here where there's a lot of discussion, then it slows down. Now, there are some exceptions to this. So for example, in the 2018 Arizona Uber fatal crash, after about 10 days, the event kind of went viral. There was a lot of discussions about it. And so that peaked and had a longer time frame. But this sort of immediate discussion and then kind of petering out is something we observed in a lot of these examples. And now moving into the sentiment analysis, we found that when we talk about, or when individuals were talking about crashes and fault and safety, especially around the fatal crashes or the minor crashes, that tended to have kind of a more negative sentiment associated with it. However, in general, the majority of conversation about AVs was relatively neutral in sentiment. So what we're seeing here is kind of a distribution of sentiment scores by tweets that were categorized in this particular topic. And then the green triangles are the 50th percentile, orange is the 5th, and blue is the 95th percentile. So you can see this kind of shift here where in the 4 topics here, they were right around neutral. And then as fault and safety and crashes get discussed, the sentiment there tends to be a bit more negative. And this is kind of another picture of that same data, but presented a little bit differently. And what we're seeing here now is the specific words and their sentiment values associated with these individual topics. And so you can see with crashes and that particular theme, discussions of kind of the fatal crash, words like accident, prosecutor, killed, fatality. These are the things that are making the crash discussions negative. And then with fault and safety, discussions of fault, worse, stop, injury, these kind of things are also pulling the sentiment negative in that direction. And one thing that it's a little bit challenging to see here is that there's a lot of inconsistency in the terminology. So we see the words autonomous, automated, self-driving, all of these are kind of used interchangeably by the public, although we know that they mean very different things from a kind of technology and technology development perspective. So from this analysis, we derive the following conclusions. So first, discussions of AV events typically center on 6 topics, as I mentioned: crashes, fault and safety, market and sales, tech companies, electric vehicles, and public transit. And that topic discussion typically peaks shortly after an event and then declines steadily in a matter of days. Discussions are mostly neutral in sentiment, although crashes and fault and safety, as I noted, were more negative. And there's a considerable variance in terms of the terms that are used for AV technology. So our last step then is to build these findings into some guidelines for social media, but we also wanted to make this approach user-centered. So we wanted to involve the people who would be most likely to be using and communicating about these technologies in this process. And we did that by conducting interviews with public information officers, or PIOs. We interviewed 8 PIOs. They represented DOTs across the US, emergency response agencies, and then other state agencies as well. 2 of these PIOs actually had experience with an AV technology rollout, and others had heard of AVs and kind of were vaguely familiar with the technology, but hadn't interacted with them directly at work yet. And the protocol we walked people through, or the PIOs through, I should say, is that we first talked about the role of the PIO in the organization, and then their use of social media platforms, their experience with existing social media guidelines, interactions with AVs, and then finally their role in traffic safety communication. And when we took this data and we performed a thematic analysis of it, we transcribed the interviews, and then we coded the transcriptions with initial codes, consolidated those initial codes into sub-themes, and then finally the sub-themes were consolidated into overarching themes across the data set. And what we found from this analysis is that first, there's a considerable variance in how agencies communicate and the roles of PIOs in agencies. So for example, with a law enforcement agency, they may be more focused on making immediate communications about a crash that's happened, for example, avoiding a particular roadway or something of that nature. Although they also kind of maintain a light presence in terms of communicating with the public and building a relationship with the public. Whereas DOTs oftentimes operate at a longer time scale where they're talking about technology or talking about new initiatives and things like that, or occasionally also communicating about kind of known big construction and things of that nature. But there was some consistency across the agency. And like I said, we consolidated that into 3 themes. So the 3 themes we identified were guidelines for general social media use, guidelines for discussing AVs, and then guidelines for building public trust. And as I mentioned, with these, they're also composed of sub-themes. So what we're seeing here is the sub-themes that are related to general social media use. And those sub-themes consisted of interaction with the public. So I mentioned with all of these PIOs, they had considerable interactions with the public that involved things like responding to questions in a timely manner. And then also sharing information, but doing so within organizational purview. So sharing only permitted information and allowing other organizations as well to be involved in the conversation. And this also came with maintaining relevant knowledge. So ensuring that both the public and the organization itself had a relevant knowledge for new trends and technologies. And then also authority, presenting information, and etiquette as well. So this was a professional interaction, and these institutes or agencies are seen as kind of agencies of authority. So kind of following that process, being an authoritative presence, but also working within the authority and the mandates of leadership and sign off. And then focusing on presenting factual accounts and correcting misinformation. And some additional sub-themes associated with general social media use. Brevity, the use of humor, and consistency. So I mentioned this kind of building a rapport, having consistent communication, and then using humor, but doing it sparingly and only in appropriate spaces, and really avoiding it in serious matters like injuries, crashes, and major safety concerns. And then also kind of keeping things brief, being able to communicate with the public, but then not kind of over communicating or just, giving the information that's needed, but not a lot more. And then finally, kind of with respect to guidelines, a firmness of guidelines, creating guidelines with clear expectations and kind of not allowing deviations from those. So having a place for them and giving them a role in the agency. And then in terms of discussing AVs, the sub-themes we identified there, the first was AV crashes and presenting them like typical vehicle crashes. And so this is was mentioned by a lot of the law enforcement agency representatives we talked to, in the sense that they typically just present an AV crash just as the same as a typical vehicle crash, and awaiting further information before sharing that the crash was either involving an AV or that the vehicle was actually in AV mode. Other areas here or sub-themes here, educating the public on AVs. So I mentioned there's a broad responsibility to educate the public, but specific to AVs, there's a need for some action around creating a program with giving regular informative posts about AVs, and this relates also to that public interaction. Also, as I mentioned, educating the organization, and then along with that, partnering with AV companies. So the PIOs we interviewed that were involved with AV rollouts, a lot of that was building a relationship with a company and helping kind of promote accurate and reasonable information with the public as those rollouts happen. So what these vehicles are capable of, what they look like, sharing things like videos and things like that so people can see it before they interact with it. And then going along with that, a need for clarity in terms. So also using terms that the public understands, but also having consistency in them so that when we're talking about a particular technology, that the term is always consistent. And then finally, understanding that, as we mentioned before, the public already has some preconceived notions. Oftentimes, those are negative and distrusting towards AVs. And then the final theme we identified, building public trust. The sub-themes here included the importance of locality, so putting local interests and local communications over national interests in terms of information. And then, as I mentioned, interacting with the public, also creating these interactive posts, like I mentioned, things like videos, and then responding to public questions, presenting information in an honest and factual manner, and then balancing this image and stability, kind of maintaining the agency as a trusted source, and working hard to kind of not violate that, especially in the communications with the public. So consolidating those or that information with the probabilistic topic modeling and sentiment, we combined that information into 5 initial social media guidelines. And these 5 are first, a focus on communicating with the public within the first 5 days of a crash, And we felt this would be most effective to get public attention, as we saw that trend where things kind of dropped off within 10 days, but oftentimes within just 5 days. The second is consistency in terminology. So in our natural language processing or probabilistic topic modeling analysis, we saw there was a lot of inconsistent terminology, and that is contrasted with the need from these PIOs to communicate with consistent terminology, as that builds public trust and public understanding. So keeping consistency in there is important. The next is that in the event that a technology brand name contrasts with the capabilities of the technology, then the guideline says to use a term from the table, and the table referenced here, I'll show the link to these in a few minutes. You can click on that to kind of read that table, which has information on very specific terms and kind of what they mean. So those terms should be used in lieu of brand names that maybe present a capability that's not technically available at the time. And then with the fourth guideline, the words fault and blame, especially in reference to drivers or automation, or being at fault in a crash, should be used sparingly. We saw that drove a lot of negative conversation on social media, so we felt avoiding those would kind of promote this better kind of calibrated trust. And then finally, public education efforts should focus on clarifying technology capabilities and assuaging fear. And we noted that the NHTSA, as well as the SAE standards, which you cited the NHTSA documentation here, are good resources for this information. So one thing I didn't mention before, but was mentioned by PIOs, is that there was some uncertainty in terms of where to go to get particular information or where to source this information, especially with things changing quite a bit. So we felt these two sources were relatively up to date and good consolidated and consistent sources for this type of information. So from there, I think broadening back or kind of looking at the overall picture with what we've talked about, I think we found that CLL, as Bert discussed, is an effective method for identifying relevant tweets centered on significant events. We also found that crashes are a substantial theme in Twitter discussions of AVs, and that crash discussions begin and end shortly after crashes or major news events. And sentiments in the discussion are relatively neutral, except for words describing fault and crashes, which are biased negative. And then finally, that PIO should focus on efficiently conveying accurate information about AVs while also maintaining this persistent interaction to educate the public on AV use and capabilities. So I have a few more things I want to discuss before we move on to questions. So as another part of this project, we actually developed some educational materials that may be of interest to those in the audience, especially those who are in education or involved in educating the public. The first is we developed an R application, and it's really designed as an activity for high school students to learn how to do Twitter analysis and then what are the kind of the steps for that. So I've given the link here, and if you have any trouble accessing this, if you're interested in it, you're welcome to email me after or Bert as well. And then we have a topic modeling and Twitter activity for graduate students in a course, and I'm happy to share that as well. And then very shortly, we will be releasing the Twitter data that we used for this. So that will be useful both in the Twitter topic modeling, but additionally for any additional analysis that folks in the audience might be interested in doing. And then as far as technology transfer, this is where I mentioned the social media guidelines. So the link is here. And again, if you missed this, I can post this in the chat as well while we're taking questions so that you'll have it. And you'll also note that in the headline for the social media guidelines, I mentioned the word initial. And I think this is something we're viewing as a living document that will evolve both with the technology and with the role of being a public information officer as those change in the face of this changing technology. So we have a feedback form here. If you interact with the guidelines at all and have questions about them, or you notice something that's glaringly missing or something that could make them better, we'd love to hear from you or hear from your organization. And so you're welcome to give that feedback on this form here. And finally, I just want to close with some acknowledgements. I'm particularly thanking Safety for funding this project and this important work, as well as the staff, including Eric and others who were really instrumental in kind of keeping us moving along and keeping us on task, as well as TTI Communications and Sue Chrysler for helping us take the guidelines and make them into something that we could publish and something that would be accessible and useful, as well as our students who, of course, drove a lot of this work. Chidabam and Shangfei worked with Bert on the CLL work, as Bert mentioned. And then from my lab, Ran, Hanana, Alec, and Jacelyn were all instrumental in this as well. Several of these folks too are looking for, or will be on the job market shortly. So if you're interested in finding students with this capability, please reach out to me. They're great, and we're very thankful for everything that they did on this project. And then last two, Michelle Canton, who was instrumental at the beginning stages of the project in getting us connected to PIOs and working with us, and Pravina Penmetsa as well, who was involved in discussing some of her work with Twitter and AV crashes and really getting us off the ground and getting us moving and giving us a good voice in our initial conversation. So thank you to all of those people. And with that, I'll open it up for questions.
Hey Tony, I'll jump in since nobody is. Zach Dorzloff. I'm curious. I've seen this kind of work around Twitter for a variety of topics, and it's really promising. I think you guys did some really neat work here. I'm also curious about other sources like automotive forums in particular kind of come to mind, because it seems like you get a different sort of maybe composer of the messages, so the individuals who are particularly sort of informed and aware of their vehicles and might identify or see trends or talk about trends perhaps in a different way than something that's more sort of broad and social and Twitter like might. And if there's sort of work in that area and any credence to it, or if it's just proven not to be effective.
I think that would be a great resource to look at. I'm not aware of any specific work on that. I am aware of some efforts in relation to comments on YouTube videos. And the comments on YouTube videos kind of posted to channels that are more oriented towards presenting technology and crashes and things. I'm happy to share that. But I think that would be a great next step to this. I think one of the things we found here is that we're missing some of the story when we're just looking at tweets. As you mentioned, there's this element of these forums where people that are very interested in this or very involved with it are having conversations. But there's also this kind of media side. So a lot of the tweets we found included URLs and links to news stories. And some of the sentiment, some of the discussion might be hidden in that information. I think Bert even mentioned we use that as part of our weekly supervised learning criteria or rules. So that's another avenue too. I think the process here in terms of probabilistic topic modeling and sentiment analysis, I think is useful for any kind of big body of text. And I would say, we've taken an initial step here, but there's definitely a need to look at things like the media and media reporting, but then also, as you mentioned, these more kind of tech-oriented forums as well.
Cool. Yeah, that's really helpful. Thanks.
Okay, so if there's not any further questions, everyone will have a chance to answer any other ask any other questions. The emails are right there. I will be emailing everybody a link to this once it's uploaded to YouTube. So once again, I'd like to thank everyone again for joining the webinar. Special thanks to Dr. McDonald and Dr. Hong for putting this on for us. Like I mentioned before, we'll upload this to YouTube, and I will notify everyone via email when it's completed. Our next webinar will be on development of a connected smart vest for improved roadside work safety. It has a date of July 28th at 1 o'clock, and free registration will be open for everybody next week. And I appreciate everybody for coming on. And I believe there's somebody sent something in the chat. I'm just gonna see. Oh, yeah. Yep, I see someone asked for the beginning of the chat, but it will be on YouTube shortly. So I'll add it up there in a sec. So again, thank you everybody for joining, and really appreciate you all, and look forward to seeing you in the next webinar. Have a great day.
Thank you, everyone.